Hello again, and let me continue with the next part of our application layer. And in this part, I will be talking about the data distribution and specifically about the content delivery networks, or CDNs in short. And to start the conversation, let us remember the basics of the client server model, so which is effectively about HTTP, SMTP, and all other things that we already talked before. In this model is simply there is a client that trying to connect to the server, and the server responds with whatever data, or like trying to send more requests to the client. That's kind of the basic model. And the main question here is how to scale. I mean, when we have just one computer, one client, one server, that's fine. But when we're talking about the scale of Google, if we're talking about the scale of Facebook, then we get into some question, like how exactly we can scale to up to million of users requesting at the same time a lot of data. And kind of there are a few answers to this question. So the generally how you can scale too many clients, like this is kind of general concept. You can either replicate servers, so just have many servers and have some kind of application logic built into the application to connect to different ones. Sometimes you can actually use DNS because DNS can return you like a set of IP addresses, but it may not be enough because DNS can still return only limited numbers. And if we're still talking about the Facebook scale, then we're talking about millions. Okay, maybe millions is too much, but at least thousands of different servers, and you need to know different IP addresses of those guys and some additional application logic to actually do that. So that's one general approach that one can take, and the other one is some kind of a caching. Like instead of every time doing processing for the request that been kind of received from the client, if we can upload this data that has been already requested somewhere, then we could be golden. And so one of the like HTTP proxy were trying to do this part, but using kind of in today's environment of HTTPS, this is no longer really the case. So if I ask the question about the previous part, like how exactly DNS system is implementing these approaches, or which approach DNS system is implementing, and I'll hope you'll be able to answer this question online. And to get back to HTTP and scalable data distribution, kind of this word CDN refers to some kind of a hybrid approach. And depending on from which perspective you looking at the CDN, it's either behaves like a cache, or it behaves like actually authoritative server. So from the perspective of kind of for the internal perspective of those CDN boxes, they're really HTTP proxies. So there's nothing more in those boxes than just receive request. If they have data, they will immediately respond with this data. If they don't, they go like somewhere inside. They request the data from somewhere inside, some kind of its own authoritative server, and then responding back to the requester. So this kind of from the perspective of internal stuff. However, from the perspective of the clients, like all of us, we don't even know that we're talking about two CDNs. So we would do like normal DNS lookup. We got like a few 1, 2, 3 IP addresses. We connect into those IP addresses, and it happened to be a CDN box. Like in many cases, it's actually some kind of a CDN box, not the actual entity. And that entity effectively kind of has a HTTPS certificate associated with the domain name and so forth. So like from the client perspective, you never tell that it's a CDN box or it's an actual server that was configured by the admin of that specific domain. So this is kind of two parts of the CDNs. Let me illustrate the same concept just using a small animation. So whenever we try to go to the some bank website, we simply type in this URL. There is some form of a DNS query. We get IP addresses, and we think that we actually connecting to the web server. If that web service or bank is actually deploying these servers, we're not going to be communicating directly. So we think we're communicating directly, but we in reality will be talking to the individual box that is close to us. So that's kind of one of the key properties of the CDN boxes, that kind of besides the fact that they cache, and besides the fact that they provide an additional capacity to the overall system, they also give you a location, like the system is giving you a location of the closest CDN box. So instead of you going overseas and trying to connect to somewhere, like going to the East Coast or West Coast, depending on when you are, you're going to be getting the closest CDN box. So that's kind of a great thing. And finally, if some data is missing, it will be communicated to the server that has the information and will be returned back. So like specifically for the bank, even let's say the bank is employing CDN services, then most likely will be employing these CDN services for things like images, some other things, some big parts. But the actual transaction, they will proxy this transaction to the actual server. There is a small danger depending on how you define this danger. If the system is really implemented and all requests are going through the, for example, the CDN box, then there's a danger that CDN box actually sees your transaction. And because kind of your security is associated between you and the first box, and what happens beyond that, you have no control, because you don't see, you don't have control of anything. In reality, the system is organized a little bit better, so there is still a connection to the some CDN boxes to retrieve images, but then there is the whole connection is going to directly to the bank for very, very important things like a transaction and so forth. And as I already highlighted, depending on where you are, you will get different server. So like without the CDN server, or like CDN service, if you're in Europe and trying to connect to some like Netflix servers that only provided by servers within the US, then you have to go like far, far, far away. And for TCP, unfortunately, it doesn't really handle too well large RTT connections, and we'll talk about this more in the next module. Versus if you have CDN and the CDN either replicate or has some kind of internal communication with that far, far away server, is still better from client perspective to have very short RTT connection to that box to retrieve all the kind of heavy, like very big information from the local CDN box versus going far, 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 far away. And there's so many different CDN services right now, and a lot of providers like Netflix, Apple, and kind of basically all the big companies that you know about, they also trying to deploy their own CDN service. Instead of relying on some specific company that to provide the service, they actually go into ISPs. They actually installing their boxes inside those networks and be happy because they don't need to pay money to CDN vendors, and ISPs are happy because they don't need to pay for traffic and for the equipment or maintenance of the equipment, because the companies like Facebook are actually providing all those equipment, maintenance, and probably even paying some amount of money to ISPs to actually put that box into the system. But this slide just gives you a perspective of how many different companies actually doing the service. One thing that I want to talk about is actually the mechanism how CDN system as a whole giving you the location or giving you IP address of the closest box. So for that purpose, as I already discussed, that there is one ability, the system gives you all IP addresses. All IP addresses, I mean, you can get all of them, but you still have no clue whether those IP addresses close to you, not close to you, how well they work, and so forth. So you have to do it manually. What CDN system is trying to do is trying to give you a very small set of IP addresses that they think is close to you, and they think that they currently working, and they have you will get the best performance. So for that purpose, there's several mechanisms, and one of them is DNS. So they're effectively abusing DNS service, as I already put up on the slide, to give you not the kind of one result. Like if you look up google.com that I was asking you to do as part of the DNS part, depending on where you are, you will get a different IP address, like different set of IP addresses. And the whole thing is, when you send a query, when you send DNS query, and maybe not you, but like your caching resolver on your behalf is sending that DNS query, the server that finally, this authoritative server that receives the final query will see the source IP address. And with this source IP address, it will run its internal database, and it kind of collects a lot of information about who is close to whom, and there's also third parties trying to do this inference. Again, it's not exact science, but they can do a pretty good job to estimate like how close you are to specific data centers. As soon as they got that estimation, they will give you the targeted results. So effectively, like in reality, like in this DNS zone of google.com, there's not a single true answer for the query. There are so many different true answers, and depending on where you are, the truthness of this answer is quite different. Like if you kind of interested about the security aspect, all of those records actually be signed, because Google given the authority to all those DNS servers to sign specific set of records, or like any records that they need to generate for the purpose of CDNing, and yet you will get different results, even though all of them technically would be correct. And to give you, this is just an additional illustration of the whole process. So as I said, the user is sending the request to the resolver sending request to the actual DNS server, like authoritative DNS server. In this specific case, it's acting as like Akamai DNS server is acting as authority server here. And with that, Akamai DNS server, instead of giving the real IP address of that, like this website that is serving the original request, it returning an IP address of some or set of the Akamai servers, and after that you will go to those closest Akamai servers if you keep sending requests for example, this google.com. The last part that I would like to mention here is there is a few caveats. So the original idea to use this DNS system, to abuse DNS system, was working quite well, because the model how DNS servers were working is like in each ISP there was a dedicated cache and resolver. Every clients were kind of forced to connect to those cache and resolvers, and not connect, but sending queries through those cache and resolvers, and using the IP address of the ISP, the CDN providers optimized or like inferred where the client is. So kind of everything was working pretty well until the Google and a few other companies introduced so-called public DNS servers. And not just introduced, but advertised, and they became really, really popular. So for example, some of you already be maybe using this 8888 or 8844, or there's also 1111 as a cache and resolver. And you can easily change the settings in your computer. Just have to go to settings, DNS, and instead of using the information supplied from DHCP, you can easily kind of manually input all those IP addresses. So the problem here is if you send requests to this 8888 as a cache and resolver, and the cache and resolver on your behalf is sending query to the CDN box, so what source address that CDN the DNS server will see? It will see whatever 8888. It will have no idea what the client was. So like at that point, there was a big problem for CDN community, and for the clients in general, because it's causing the problem to everybody. So the community and like protocol designers and DNS designers actually was forced to introduce additional component to the DNS query to proxy IP address of the guy who sent you the query. So effectively, when you send a query to google.com, Google not just proxy send your query to different servers, but also include who originally asked this question. And to summarize, for the client, the server model for the data distribution, you really need to have enough capacity to serve clients. And to have this capacity, you either provide enough servers in different places, or you introduce also caching. And as part of this effort to introduce both some form of a caching and some form of a capacity of authoritative servers, content delivery networks, they deploying the servers, deploying some capacity of the servers that can act as both effectively in different places of the network. They do it, and they try to introduce their services, their data centers in basically every ISP. So they relatively close to everybody. And as such, they, instead of you going to the actual server, you, like using this DNS tricks, being redirected to one of those boxes that is close by. And this optimizes your RTT time with the communication. May not work in all cases, like in case that you still can, if you're requesting data that is not available and it needs to be requested somewhere far away, then you still have some additional time to wait for this data. And you maybe have experienced this part when you requested, we tried to go to Netflix or something, and you requested not very popular movie. So for the popular movies, you're like clicking and everything is almost immediately being downloaded or like working. If you request something that basically nobody's watching, it's taking time for buffering and so forth. So this is effectively a potential effect of that the closest Netflix box doesn't have the information and has to go far away to fetch this information, bring it to your closest box, and then you'll be able to actually watch the movie. And for the DNS part, yes, the DNS is trying to infer your location based on the source address of the request. That's kind of was working very well with the traditional caching resolvers, and still working well with this additional modification to DNS protocol. So the caching resolvers still tell you authoritative servers something about you, like specifically IP address or subnetwork address of the guy who requested the information. Okay, so I hope it was interesting. I hope you learned a lot about the CDNs, and now you can answer a lot of questions about CDNs.